Hello everyone. Welcome to another video of Sigmoid Tech Talk series. I am Prateek Sinha, lead data scientist at Sigmoid. In this video, I will discuss about price and promotions model. This is a solution we created for solving a challenging problem for our client. The client we were working with is a leading producer of health, hygiene, and nutrition products. It is in the CPG industry and it has markets all over the world in UK, Australia, and USA. The product categories that we are working with are kitchen wash, dishwash, and air care, etc. Now let us look at the business problem that we are solving. The business problem was that the brand and trade marketing teams needed a data-driven solution powered by machine learning to help them take following decisions. First of all, baseline demand forecasting, which is basically forecasting sales for items in future without the effect of promotions. Another decision was about at what price a certain product should be sold. And there were thousands of products, and taking decision on all those products was difficult. Next, they wanted to simulate different promotion strategies and find optimum level of trade or promo investments. Taking all these decisions into consideration with other data sources like production cost and variable cost, as well as promotion investments, they wanted to maximize the profit and loss and return on investment on different promotion investments and different strategies that they would take up for different products. So this was the business problem. Now let us look at what solution we created. In this slide, we can see the overview of the solution. First, we can look at the input data, which goes into PNP, gives the output, and this output was used by the brand and trade marketing teams for several decisions. The input data is basically the Nielsen point of sales data, which is the sales data of different items at the level of retailer and for each weekends. It also had price and promotions data. Other than this, there were holidays data. This would go into PNP and give model results, which is basically price elasticity, discount, and promotion uplifts. These are values which tell us by changing 1% of price, how it will affect the sales of that product. Similarly for other features as well. The other output that we were generating is base sales forecast, which is the sales forecast without the effect of promotions. And if we know that, then we can simulate different promotion strategies. We can add effect of different promotions and see how it will affect the sales. So in this way, the brand and trade marketing teams was using this data to take decisions like optimized promotion strategy, future estimation on inventory requirement, optimum price or discount at which an item can be sold. Now in this slide, I am showing the representation of each of the input and output data. First, we can look at the input data. Input data was at the level of each retailer and item, and for each weekends, we had price, promotion, and sales data. And this data was for last 2 years. Holidays data gives us what holiday lies on which date. This would go into PNP and give model results, which is basically at the level of retailer and item. Each combination had price elasticity and discount and promotion uplifts. Other output we can see can be represented like this: at the level of retailer and item for future weeks, what would be the expected base sales. So this was the representation of data, and in total we had 1.4 million rows in the input data, and we were modeling 2000 unique items. In this video, I will discuss about the PNP architecture in detail. So in this slide, we can see the whole PNP architecture and with all the important pieces of the solution. First, the input data, which goes into data preparation. Then the next step is modeling, which gives finally the output. As we have already looked at the input data, it is Nielsen point of sales data as well as holidays data. This goes into the data preparation stage. And in the first step, we do delisted and newly listed item detection. In this step, we identify which items are no longer sold in the market and which items have been newly introduced into the market. After this, we do base price estimation, which helps us to estimate discount. The next step is to identify competitors. Here, by competitors, I mean the similar products to the item that we are modeling, and we call it competitors because their promotions or discounts can affect the sales of the item being modeled. So after this step, our model input data is ready, which goes into modeling, and we adopt the modeling approach of constraint regression, which is a linear regression method at business conditions. After we model all the items, we get the coefficients of different features for each retailer item combination. We use the trained model as well as those coefficients to forecast base sales. And in order to forecast base sales for future, first we also need to forecast each of the features, which we forecast using Holt-Winters forecasting method. So in this way, we generate both the outputs, the model results, as well as the base sales forecast. Next, let us discuss in detail each of the steps of data preparation and modeling. So the first step is delisted and newly listed item detection. Here, the challenge was that we wanted to include only relevant period for modeling for all SKUs. In the first example, we can see for this item, the sales are going to zero after a certain period of time. So for modeling this item, we should only include the valid sales period. So first we need to identify the delisted item and then identify the period in which it has valid sales. Similarly, for this item, this is an example of newly listed item because it was not sold in the market, but it was introduced and we see some non-zero sales happening and it after a certain period of time. So this is an example of newly listed item. After this, let us discuss about the base price estimation. The challenge here was that we did not have discount data, which is an important feature for predicting sales. So we had to estimate discount and we estimated it using the price data that we had. So in the first plot, we can see the price data variation for one of the items. First, it is at $8, then it is changing to 11, and like that, it is oscillating between 8 and 11. So in order to identify what is the discount on this item, first we need to identify the regular selling price or the MRP. Here in this case, it should be $11. So once we estimate the RSP, we can subtract price from RSP and get discount. In other case, in the second plot, we can see RSP is 15 at the beginning and it is going to 12 in the later period. So there are various variations in the data that we had to counter and we had to find a novel approach, and we solved this using base price estimation based on global and local maxima approach. This is the third session on price and promotions model solution, and in this session I will talk about PNP modeling and some of the other challenges that we had to face and how we solved that. I am Prateek Sinha, lead data scientist at Sigmoid. So first let us look at the modeling approach that we had to use. The challenge here was that we were modeling thousands of products and we also had to create accurate model for all those products along with several business conditions. Let us look at what those business conditions are. First example is that no positive own price elasticity. It means that if we increase the price of a certain item, its sales should always decrease. And similarly, if we increase the distribution of an item in market, its sales should increase. And if we increase the discount or promotion on certain item, its sales should also increase. In terms of equation, which is a regression market mix model equation, we can say that beta 1 should be smaller than 0, beta 2 should be greater than 0, and beta 3 comma beta 4 should be greater than 0. So we had to do regression, but we also had to satisfy business conditions. And if we used general regression technique like elastic net, there was risk of dropping relevant features like price, discount, promotions to meet business conditions. So in order to solve this problem, we used constraint regression, which is a linear regression model within boundary conditions on coefficients. We can define the conditions on coefficients like beta 1 smaller than 0 and beta 2 greater than 0 and like that. And the model will train within that boundary conditions only. We use the SciPy implementation of constraint regression, and this approach led to improvement in error rate from 35% to 15%. So now we have discussed the modeling approach. Let us look at, in terms of data, how the model input data looks and how the results are created. So you can see the model input data. It is basically all the model features which go into the model. So important features were price, promotion, sales, discount at the level of retailer and item for the past 2 years. These are the weekends. And this goes into the modeling module and gives model results, which is basically the price elasticity, discount uplift, promotion uplift for each retailer item combination. Next, let us discuss one of the major challenge that we faced, because we were working with a large input data close to 1 GB and the unique items that we were modeling was 2000. Because of such a large data, the sklearn based modeling implementation had a runtime of 100 plus hours. This made the product being not so viable for business, and also it made experimentation slow. So in order to improve and optimize this modeling, we used Spark based parallelized implementation on Databricks. This ensured parallel model training of multiple items. For one of the markets, we were modeling 16 items at once. This led to 86% reduction in total runtime from 100 hours to 14 hours. So at the end, in this slide, we can see a summary of all the challenges and the solution that we used to solve those challenges. First, we had to include only relevant period for modeling for all items. So we used delisted and newly listed item detection using time series breakpoints to solve this. Next, we didn't have discount data, so we did base price estimation using global and local maxima approach. Next, we had to do accurate modeling for thousands of products along with several business conditions. For that, we used constraint regression, and the major challenge was huge training time, close to 10 days for large markets. In order to optimize this, we used Spark parallelization. So we come to the end of Tech Talk on price and promotions model. Hope this was useful to you. Thank you.